Okay, hello. So, for those that are tuning on recording, okay, I do apologize again that if you're unable to join the session. Okay, so for future sessions, I'll prep for more people, okay, and ensure that there will not be any more like technical difficulties lah. Okay, so I do apologize for that on my behalf. Okay, so first thing, let's start first. Okay, so hang on now. Oh no. Okay, so yeah, let's begin. Okay, so yeah, I actually wanted to start earlier because I didn't want to hold people back. Okay, so I'll just zoom straight into the content. I wanted to go through the paper one, okay, but then I don't think there is much time, so I don't think I will. Okay, so I'll just go straight into the paper two. Okay, so yeah, I posted some prediction notes. Okay, so let me show you. This is the document that I prepared earlier. Yeah, send it out together with the paper one solutions. Okay, so this document here, I will prepare it usually for every single year. Okay, and it will actually entail the topics that are that haven't been tested for the paper one and most likely will appear for the paper two. Okay, so if you haven't taken a look at it yet, okay, I will be actually be going into detail as to what are some things that you need to take note of and some of the common mistakes and whatsoever for the next 1 hour until about 11:30. And then once I'm done, then I will stop the recording. I'll post the recording onto the Overmark channel. Okay, then after that, I will start the consultation session lah. So that one is for anyone that wants to join. Okay, so I mean I kept at 800 lah. So yeah, I understand that the words are a bit small. Okay, I'll zoom in. Okay, so yeah, okay, so I'll post them onto the channel, okay, so that everyone can see. Okay, so let's start. Okay, so number one, okay, so this is the document that I have prepared. Okay, so it will entail everything that you need to take note of lah. So one thing that I need to say first is that these are predictions. Okay, I do not have the paper, so I cannot tell you. I'm not a guru lah. Okay, I cannot tell you what is going to come out later. Okay, so everything is just based on experience and based on what I think will come out. Okay, so yeah, let's start. Okay, so I'll go into my notes document. I will send out this document later also, and I'll be writing some stuff here as well. Okay, so I do apologize if it's a bit small. I'll zoom in. Okay, so let's begin. Okay, so for the first chapter, it will be numbers and the four operations. Okay, so for numbers and the four operations, these are the three things that I think that will be coming out later. So we have standard form, prefixes, and fractional indices. Okay, because these are the three things that didn't come out so far. Okay, we start with standard form first. So everyone needs to remember that for standard form, right? Okay, let me just write it down. Oh shit. Okay, so for standard form, okay, so some things to take note for standard form, right, is that we need to remember that it is always in this format, a times 10 to the power of n. Okay, so this is the standard form format. Okay, and we need to remember that the properties of a is that it's always between 1 to 10. Okay, so whenever you are dealing with standard forms, please remember to change whatever the question gives you into this particular form. It cannot be anything else. It cannot be like 0.3 times 10 to the power 7. This is not possible. It must be an integer number in front, okay, whenever possible. Or sometimes if it's a decimal, it must be like 1.3, 1.4, okay, then it's to the power of n. Okay, now n can take any values, but n is most of the time an integer as well. Okay, so just take note of that. And now last thing, in case you didn't know, the calculator is actually able to help you type things in standard form. Okay, so what you need to look out for is this ENG button. We call it the engineering button. So this engineering button here, right, is able to help you convert your numbers into standard form. Okay, so my video is on. So if you can look into my video, this is the button that I'm talking about right here. Okay, wait, let me just check if I cannot see myself. Hang on. Yeah. Okay, so oh dear, it's so blurry. Hang on. Sorry, pardon my messy room, but yeah, this button right here. Okay, so if you click this button right here, okay, this engineering button there, okay, you'll be able to convert all of your answers, okay, into standard form, but you must be very careful because the calculator will not give you this exact a to times 10 to the power of n format. Okay, it will give you like something else, so you need to be very careful to always write back into what you're actually taught in the syllabus. Okay, so this button is pretty powerful, so remember that. So this one is on the calculator. Okay, so apologize. In my handwriting it's a bit trash now. Okay, so I'll try to write as I can. Okay, next is to go into prefixes. Okay, so prefixes didn't come out, and the chances of it coming out is very high. So later, what I will do is that I will break down what I believe the 10 questions are going to be, and we shall see in the next 4 to 5 hours, we shall see whether my predictions is correct or not. Okay, so for prefixes, now we always need to remember all the way from tera to pico. Okay, so go all the way from tera all the way to pico. Okay, there's a very long list there. If possible, go and memorize them. Okay, tera is 10 to the power of 12, pico is 10 to the power of minus 12. Okay, so all of these in between, like the mega, giga, kilometers, or kilo, centi, deci, all the kind of numbers, right? Okay, please try to remember. Now, okay, try to remember them. I have actually a little list right here that I prepared. So let me open my created notes. Okay, so yeah, okay. So it will be something like this. Okay, so this whole list will be given here. Okay, so now it really depends on how much you have learned. Most people learn until nano or something and giga. Okay, but if you have never seen pico and tera, then it's fine. Okay, but especially these few in the center here are pretty important. Okay, so go ahead and take note of it. What they are, because sometimes it's actually not given in the question. They will just tell you like, oh, an atom is the size of 5 nanometers. Convert this into in standard form, for example. Okay, so you need to know that nano is 10 to the power of minus 9. Okay, or else you will get it wrong. Okay, so it really depends on the year. Some years actually they don't. Some years they don't give it. Okay, some years they do. Okay, so this is for prefixes. Last one is for fractional indices. Okay, so what's the reason why I say fractional indices? Okay, so indices did come out for one question, which I believe was wait, hang on, let me flip through my solutions. Yeah, it was this. Okay, so this came out. Okay, so this is the only indices question that came out. Okay, so there can be any other things that come out. What I mean by fractional indices is this kind of question. So 24a to the power 4 over maybe like bc cubed times c square over b3. Something like that, okay? Something along these lines where you will need to cross and put them together. Okay, so these are the kind of questions that you should take note of. Okay, so yeah. Okay, to help those with the prefixes one, why not I do this? I screenshot. Okay, so yeah, these notes here will be posted later. Okay, because I do need to move on. Okay, so just remember that this list is pretty important. Okay, so try to memorize what the nano means, what the micro, pico, and everything really means. I'll post it into the Overmark channel. Okay, so the Telegram channel. So this set of notes will go along together with the recording, this recording right here. Okay, so let's move on. Okay, so we'll go on into percentages now. So for percentages, this one is not a very big topic. Okay, so not too much that I want to talk about, but one thing is about the profits and loss. Okay, so profits and loss always appears together with those kind of monetary questions, which I will talk about at the back. Okay, and then we'll have the percentage increase and percentage decrease. Now, for the paper one, there was one question on percentage increase and percentage decrease, okay, which was the proportion question. So this kind of concepts can appear again. So let me go through what they mean. So for percentage increase or decrease, okay, remember is this formula, final minus initial over initial. times 100%. Okay, so remember that this is the mean formula. Okay, so final minus initial over initial times 100%. Okay, now one thing that I need everyone to take note of, okay, is that if the question states that this is a reduction, okay, and you actually get a negative value, is correct. Okay, you're actually supposed to get a negative value, but, okay, let me write a but, but when you write your final answer, it needs to be positive. Okay, so when writing final answer, need to be positive. Okay, so yeah, these are the things that you need. So for the reduction, okay, if the question states that this is a reduction question, okay, so for example, the question is asking you what is the percentage reduction of something, okay, and the value that you calculate out is actually negative, you're actually doing it correctly. But you must remember, whenever you're writing it onto your answer line, it needs to be positive because the reduction word already implies the negative sign. Okay, now if the question says percentage change, so if the word is a change, then you need to write the negative sign. Okay, so for example, if it's the word change, okay, then you put as calculated. Okay, so you all right here, put as calculated. Okay, so this is how it should be done. Okay, I'm not very sure. Okay, later I'll talk about it. Okay, so yeah, this is the mean bulk over percentages. Now, percentage change and increase, decrease always comes out. Okay, so it will just pop out randomly. So it's very important to know these concepts. Okay, next one will be algebraic expressions and formulae. So just now I saw some comments about it. Okay, so I'll talk a little bit about it now. Now, number one will be changing the subject of a formula. Okay, so let's go through that. So change subject. Okay, so whenever you are changing the subject, there are a few things that you need to take note of. Okay, number one, remember to plus minus. Okay, because this plus minus sign is something that will trick a lot of students. Okay, so remember whenever you are square rooting both sides of the equation, you need to plus minus. Okay, if you don't plus minus, you're going to get the question wrong. Okay, number two, now the standard methods for changing the subject of a formula is to always group whatever you want on one side and throw whatever you don't want onto the other side. Okay, let me just demonstrate, okay, with an example. So let's say, for example, if I have an equation that is like, okay, I'm going to BS something in my head. X squared plus CY equals to,
Yeah.
equals to bx squared plus 2f. Okay, for example, if it's something like this, okay, so what I will do, I want to make x the subject. Okay, so what first thing I will do is to keep all the x's together. Okay, so I'll keep the x's together. Sorry, I won't be doing the transcription. So yeah, stop asking for it. Thanks. Okay, so I have an x squared here, a minus b equals to 2f minus cy. Next, I will throw the x down. I'll throw the a minus b down. So it's 2f minus cy divided by a minus b. And then this is where you need to remember to plus minus. Okay, so 2f minus cy, a minus b. Okay, so the trick here, okay, is to remember to always keep the numbers right here. Okay, keep the thing that you want onto the very corner. Okay, and also whatever you want, okay, then you just throw it away. Don't want throw away, and then you must remember to plus minus. Okay, so whenever you're dealing with squares, please remember to do that. Okay, or else you'll get it wrong. Okay, yeah, you just need to write this symbol here. That is good enough already. Okay, next one. We're going into constructions of equations for quadratic. Okay, so I've already put a disclaimer here. Okay, that involves proving and solving of quadratic equations that is specific to paper 2. Okay, so for this particular one right here, now this is one of the questions that I predict will confirm come out. Okay, which will be where they give you a scenario. Okay, where like for example, let's say you'll always be broken down into 5 parts. Part A will be like, oh, this person travels to town B at a certain speed and distance. Find the value of the time. Part B, given that she travels 2 km per hour faster, then after that find the time in part B. Part C, given that the total time is 20 minutes, okay, form a quadratic equation. Part D, solve the quadratic equation. Okay, and part E, find the time. Okay, I'm talking about those kind of questions. Okay, so when you're talking about the construction, so now a few tips. Okay, number one, don't ever give up on the quadratic equation question. So number one, don't give up on the quadratic. So always solve the quadratic. Okay, so let's say, for example, if the proving question you cannot prove, always just solve the quadratic first because that will give you the answer. Now, remember that for the quadratic line, you need to show working. Okay, so be it the quadratic formula, so x is equals to negative b plus minus the square root of b squared minus 4ac over 2a. Be it this or be it the box, okay, or whatever way you guys learn, the diamond shape or the square. Okay, whatever ways that you learn to solve quadratic equation, okay, just remember that you need to show the working, and usually how far you need to show. Okay, I got slipped before. So sorry, let me look for it. Solving quadratic equations. Oh dear. What you? Here. Okay, so intermediary steps. Okay, so you need to always show all the way until here the solving of whatever is inside your square root. This is necessary, and you need to show the box. Okay, all these kind of workings are important, so please remember to show. Now I know there are people there that can eyeball the quadratic out. I also can do it. Okay, so the thing is that I will still write it as a solution in my answer. Okay, so be a bit more kiasu in exams. Okay, please remember to write this kind of things. Okay, so this is the thing that I was talking about. Now, the quadratic part, okay, just take note that it's 3 marks. Okay, it's very, very easy. You can always check it using mode 33. So mode 33 on the calculator. Okay, so this is something that you can check with. Okay, please do not just type mode 33 and write the final answer. You're not going to get it correct. You need to show working at the very bare minimum. Now, for this kind of quadratic questions also, remember that there are a few question types also. Okay, it's not just the distance questions that I was talking about. There are a few more. Okay, the most difficult one out there, okay, will be the monetary questions. Okay, so it's those kind of questions where they talk about, like, let's say, okay, I have a batch of apples that I'm going to sell. Calculate how much is one apple. Part B, the question states that, for example, I give a discount and 2 of the apples will not be sold. And I don't know what, okay, then part B will ask you what is the total price or something. Okay, so whenever you are going for total price, remember, the total price is number of items, okay, multiplied by the price. Okay, so usually this total price part will stump a lot of people, and usually this is the most difficult kind of equation to form. So if you are stuck here, okay, it is okay to just give up and go. Okay, because this is where things get a little bit more difficult and where questions will split for your A1, A2, and everything. Okay, so yeah, this kind of questions hasn't appeared in O levels for the past, I think, 7 to 8 years already, if I remember correctly. Okay, so it may appear, it may not appear, no one knows. Okay, now we move on to completing the square and then number patterns. Okay, so I didn't expect myself to write so big, so write it here instead. Okay, so we go into completing the square. Okay, now for completing the square, it always comes out together with those kind of graph sketching or quadratic sketching questions. So in the event you're dealing with those kind of graph sketching questions, then I'll talk about it later. But let me first talk about the techniques of going through completing the square. Okay, now I always teach my students a certain way to do completing the square. Okay, and this is the method. Okay, so if you've heard it before, then good for you. If you're the first time hearing it, then just take note. Okay, let's say, for example, I'm going to use the exact same example I always use. Okay, I want to complete the square for this. X squared plus 6x plus 12. Okay, now first thing I will always do, okay, is to always write down the brackets first and then put the number all the way at the corner. I will purposely leave a gigantic hole here because this is a number that I need to fill in later. Okay, now what I'm going to do next, okay, I'm going to use workings in blue. So if there's an x squared here, you're going to put an x. If there's a plus sign here, you put a plus. Okay, so the plus sign there, right? If let's say your question is a minus 6x, then you put a minus sign. How about this 6x here? What I'm going to do, I'm going to become a 3. And what's the reason? Okay, reason I'm going to put in green. Okay, the reason here, I'm going to just do the coefficient of x divided by 2. Okay, so whatever number it is, let's say if it's a 5, okay, it'll be 5 over 2. Let's say, for example, if it's a 7, 7 over 2, 16, answer will be 8. Okay, so this is how you split up your values. Okay, so x plus 3 whole thing squared. And then now how to figure out this lobang. Okay, this whole here. Okay, there are two ways of doing it. Usually for people that are slightly weaker, what I will tell them to do is to expand. Okay, so when I expand this, I'm going to get this equation here. Okay, and then I'm going to start comparing. Okay, because I say that both equations are the same, so this and this must be the same, means that I cannot have anything extra, cannot have anything that's less. Okay, so x squared, very good. 6x, 6x, very good. Plus 12, very good. But there's a plus 9. Okay, so this thing here is extra. So if you have something extra, you need to remove it. Okay, so you minus 9. Okay, and we are done. Okay, this is the completing the square answer. So this will be x plus 3 whole thing squared plus 3. Okay, now negative completing the square is not in O levels, is in A math, not in E. Yeah, so that one most likely won't come out. But let's say if it does, the simple method is just to factorize out the minus sign. Okay, so I give you an example. If let's say it is negative x squared minus 6x plus minus 12, sorry, I pull out the minus sign. Okay, and then after that, I'll just complete the square using this. Okay, so this is just a way to do completing the square. Okay, sorry, let me check some stuff. Okay, so yeah, let's move on. Next one will be number patterns. Okay, for fractions, right? Okay, my general rule of thumb is that I always write it in mixed number. Okay, of course, it's a very controversial topic, whether to leave your answers in improper or whether to leave it in mixed number. Okay, so I don't know whether you saw that little discussion on the discussion chat, but yes, my personal opinion is to always leave answers in mixed number. Okay, and to never ever leave in improper, because the nature of the word improper means it's not proper. So you should never ever leave your answers as not complete. Okay, so always, if possible, leave your answers in mixed number. But make sure when you're leaving it in mixed number, it is correct. Okay, don't kiasu and then you get it wrong. Okay, so yep. Next one I want to talk about is number patterns. Okay, so okay, so for number patterns, right? This is a topic that I cannot help you a lot. It really depends on the question. Okay, and my very high guess is that this will be one of the big questions. Okay, later. Okay, because they always like to test like one 10-mark question on number pattern. Okay, it's a very common trend these few years. Okay, but there are some things that I can guide you on. Okay, I cannot specifically tell you what formula to memorize, but I can guide you to getting the correct answer. Okay, so we first talk about the ones with common differences. Okay, so we talk about common difference first. So common difference means that the numbers are jumping between the same numbers. Okay, so I give you a demonstration. So let's say 1, 3, 5, 7, and 9. Okay, so these numbers here are all jumping by 2. Okay, so how do we write the formula? Now remember that this is the main formula. Maybe I'll write it later. Okay, this one is a very important formula. Tn equals to A plus n minus 1 times D. Now I know there are people that didn't learn this because this is actually not in secondary school syllabus. This is in A levels. Okay, it's called AP. Okay, but it's very powerful. That's why I decided to teach it this year, and some schools in Singapore do teach it. Okay, so this formula is very useful because it helps you figure out number patterns of common difference. Now, this is something I need to stress. Now, for those that came for my crash course, I think you hear me say this statement before. Please be very careful. It must be common difference. It cannot be anything else. If it's something else, let's say, for example, if it's the interval jumps are like 2, 3, 4, 5, you cannot use this formula. Okay, you will get it wrong. Okay, so let me explain what is A, what is D. Okay, so A is the first term. Okay, and what is D is your common difference. Okay, so let me solve the question now. This will be 1 plus n minus 1 multiplied by 2. Final answer is 2n minus 1. Okay, so this will be the answer. And if you don't believe me, just plug it in. Okay, if you put n as 1, you're going to get 1. If you put n as 2, you're going to get 4 minus 1, which is 3. Okay, and the pattern works all the way. Okay, so this is for common difference. Now, unfortunately for the rest, let's say if it's jumping by like 2, 3, 4, 5, that one I cannot tell you a formula because there is no fixed formula for it. Okay, those you need to work it out on the spot. Okay, but there are some tricks to help you work things out on the spot. Okay, so yeah, okay. So there are some little tricks that we can do to work things out on the spot. Okay, so let's say for example, if I have a pattern that looks like this. Okay, there's no answer for this. I'm just BSing something in my head. What I will do is I will always label this as term 1, term 2, term 3, 4. Okay, and then what I will do is to form a relationship between the 1 and the 1, the 2 and the 4, the 3 and the 7, the 4 and the 10. This is one way to actually get out a number pattern. Okay, now there are two other question types that I want to cover, okay, which is the grid questions and the ones with a lot of formulas. Right? So I'll talk about the formula one first. So let's say the question gives you something like this. 1 square multiplied by, okay, 1 square minus 2 times 1. Term 2 is 2 square minus 4 times 2. Term 3 is, okay, maybe not 2. Let's do something else. Let's do a square and put 3 here. 3 square minus 6 square times 5. Okay, so what happens if like this and they ask you to find what is Tn? Okay, so what is the technique? Okay, I know like that, right? You see what scary. Okay, actually it's not difficult. What you do is you look at like this. Okay, you break it down into 3 sets of patterns and then you write out your pattern. So we start with the 1 square, 2 square, 3 square. Okay, so 1 square, 2 square, 3 square is obviously just n square. Okay, then you follow the minus sign. Now, how about 2 square, 4 square, 6 square? What do you notice? Okay, this is a 1 goes to 2, 2 goes to 4, 3 goes to 6. You're just doubling every single n number. Okay, so it'll be 2n squared. Okay, and you need to square because of the square up there. Now you have a 1, 3, 5 pattern. So write it out 1, 3, 5, 7, whatsoever. You can see that the intervals are going by 2. Okay, so this is just an AP formula, 2n minus 1. Very good. Okay, so this will be 2n minus 1 and just multiply. You just need to expand and you get your answer. Okay, you will get a cubic answer. So this is usually how we do it whenever we want to break it down. Okay, so yeah, this is one type of questions. Now the last one that I want to talk about is the grid. Okay, so we go into the grid. Now the grid kind of questions are those with a gigantic box of numbers. Okay, I believe this one, if you have been practicing TYS, you have definitely seen it before. Okay, so the grid of numbers. And then they will tell you that in the center you have a grid. Okay, let's say I'm just going to throw some numbers out. 1, 7, sorry, mental sound very bad. 13, 19. Okay, so let's say for example, if the question tells you that I have a grid that looks like this. Okay, I want you to figure out the pattern. Okay, so what we always do, and most of the time they will never give you here, they will give you somewhere in the middle. But I don't have the time to go and figure out what the numbers are. Okay, so if you're given a grid like this, always just write it out properly. 1, 7, 13, 19. Now the very unique thing about grids like this, the numbers are always jumping by the same value. Okay, so if you look, this is just a 6, 6, and 6. Okay, so if the first term is t, baby t, this will be t time t minus 18. So 18 minus t plus 18. Okay, so you'll be something like this. Then for this one will be t plus 6. This will be t plus 12. Okay, so if you remember to the year, they ask you what is the product of the first term and the fourth term, and then explain why the difference between the product of the first term and the fourth term minus away the second term and the third term gives you a factor of something. Yeah, so you just need to take this times this, and so on. Okay, so this kind shouldn't be too much of a problem. Now just take note, okay, that there are different ways of configuring this grid. Okay, you can go down like this. It can be, I think there's one here that is a 2x2 box. Okay, I have seen questions that is like a T shape. Okay, I have seen questions that is an L. But if they really want to disturb people this year, they will do diagonal. Okay, so it can be anything in the world. Okay, so it really, really depends. Okay, so these are the main type of patterns that we're talking about. Okay, so there are many numerations of this kind of questions. Okay, so if you've been practicing your TYS, you will know what I'm talking about. Okay, if you don't, then you never practice enough. Okay, so these are the main types that I'm talking about. Okay, very good. So I'm actually done with number patterns. Okay, so if you have more questions on number patterns later during the consultation period, then you can ask me now. Okay, so let's start with functions and graphs. Okay, so okay, I have a lot of chapters now, so I need to rush a little bit. Okay, yes, for diagonals is always common difference as well. Okay, for functions and graphs, just take note that there are a few things to remember. We talk about the basic form, which is y equals to, sorry, my pen is too thick. Okay, we'll go for the basic form, which is y equals to ax to the power of n. Okay, so if you are dealing with this kind of form, sorry, give me a second. Okay, so if you are dealing with this kind of forms, remember that there are the 6 most famous graphs out there. Okay, so let's just check what they are. Okay, this is just a revision now. A straight line, a curve, a cubic curve, reciprocal odd, reciprocal even, exponential. Okay, so there are 6 in total that we all need to remember how to sketch. Okay, just some ways that I memorized. This is a line, obviously. This is a cup. This is a slide. This is a basketball. Volcano. Banana. Okay, this is just some of the ways that I remember my graphs. Okay, and the relevant equations: y equals to x, y equals to x squared, y equals to x cubed, y equals to 1 over x, y equals to 1 over x squared, y equals to a to the power of x. Okay, so these are the standard forms of equations that you need to know. So they may ask you to like plot, or they may ask you to like label the graph, or like decipher what kind of graphs they are. Okay, there was a year that came out this kind of questions. It was the one with the negative 5x squared, or the 5 minus x squared, 5 plus x squared, all the kind of questions where they ask you to label. Okay, usually there's a paper 1 question, but you never know. Anything can come up. Okay, so just remember this. Last one's 2 more concepts, which is graph sketching of quadratic curves. Okay, so whenever you're dealing with sketching of quadratic curves, remember that there are 2 forms. Okay, so let me split my paper into 2. Okay, there are 2 forms in total. So we'll talk about the first one first. Okay, so there are 2 forms. Okay, how do you tell the difference? Now for this one, we call it the completing the square. Okay, let me just write CTS. Okay, and this one is what I call it the x-intercept. Okay, so there are differences between the 2, and they both give you different things. Okay, for the completing the square, they give you the turning point. Okay, and the turning point is given as h comma k. Okay, you must take note, this is a minus sign. Okay, so if it's a negative h, this means that the h value that you're putting right here must be positive. Okay, if it's, let's say, x plus h, then the h value is negative. Okay, please be very careful. The k value just follows as per written. For the x-intercepts, like the name suggests, this provides to you the x-intercept. Okay, the values are just a comma 0 and b comma 0. Okay, so these are the two things that they provide. Now, usually I will tell students to always have a checklist of what to look out for whenever you're sketching questions like this. Step 1 is to find the x-intercepts. Okay, you sub in y equals to 0. You know for the y-intercepts, sub in x equals to 0. Okay, next is to settle whether is it a happy face or a sad face. You look at the coefficient of x squared. And last one is for the turning point. Now there's a difference between the two. Okay, I'm going to label this as equation 1, equation 2. For equation 1, okay, just read off. For equation 2, we find the midpoint of the x-intercept, midpoints of the x-intercepts, and then you sub the midpoint into the equation. Okay, so these are the concepts here. So x-intercepts, y-intercepts, coefficients of x squared, and then for the turning point, if you're given the completing the square form, okay, you read off the graph. If you're given the x-intercept ones, you just find the midpoint. Okay, midpoint is just average of the two x-intercepts given. Okay, you sub it into the equation. You'll get your minimum point. Okay, so just take note that curves must be drawn beautifully. Please do not anyhow draw. Do not. I've seen graphs that like that, like that. If it's a curve, it's a curve. Okay, please make sure that it is drawn properly and yeah, make sure it's beautiful. Okay, so these are the graph sketching portions. Now, last one I want to talk about is the applications. So this is something that I've added in last night. These kind of questions here are the most difficult kind of application questions. So reference to you will be 2018, paper 2, question 10. The Huna question, where she has a box with the given equation of x 30 minus 2x, 20 minus 2x, this equation. Okay, so where this one, they didn't give you a table with numbers. Usually these are the most difficult type. Okay, so just take note that it may come out, but I don't think so because paper 1 already had a graph sketching question. Okay, for extrapolation, no. For curves, we don't. We only stop at where the x points are. So the question will usually define where your x's are. So if let's say x stops at 0 and 10, you stop at 0 and 10. You cannot extend past the curve, you will get it wrong. Okay, so extrapolation, no. Extrapolation is only for linear law in AMF. So you just ignore that extrapolation portion. Okay. Next, equations and inequalities. Okay, sorry if I'm going quite fast. Okay, if those that don't understand what is extrapolation, then forget it. Okay, because it's not in the syllabus. For simultaneous equations, okay, so we talk about that. I think this one is pretty basic. Okay, so for simultaneous equations, okay, okay, so yeah, for any questions, please put it into the main chat if possible. Don't PM it to me. Okay, so for simultaneous, okay, where do you draw the table? Whatever answer space that you have. For simultaneous equations, right? Remember that there are 3 methods to solving: substitution, elimination, and graphical. Okay, so these are the 3. Okay, so substitution is the one that I preach the most because I mean I do AMF, I teach AMF. AMF only uses substitution, so that is the main method that I will go for. Elimination is the one where you take like the different values and then you make something, or you just like if both equations have a 2b, then you just plus or minus the both equations. For graphical is like, for example, if your curve cuts a line, okay, then you just do simultaneous between the graph and the curve and the line and solve for the solutions. Okay, so these are the 3 methods. Most of the time we just use first 2. Okay, next one, solving of quadratic equations using the quadratic formula. This one usually will test together with the forming of quadratic equation questions. Okay, so it will be x is equals to negative b plus minus the square root of b square minus 4ac over 2a. Okay, so this is the equation here. Hey, what's your language? Okay, so I don't need to say that. Okay, but please mind your language. Yeah, quadratic formula. Okay, so please take note that it is provided in the formula sheet. Okay, so remember to use it. Okay, and you must remember your A, B, and C lah. Okay, so if the equation is ax squared plus bx plus c, remember your A is your x squared, your B is your x, and your C is your 0. Okay, next, linear inequalities. Okay, so for linear inequalities, right, remember that there are a few question types out there. Okay, the most famous one is this one here, which I will show you. Oh, here. Okay, so for linear inequalities, right, whenever you're dealing with the drawing of a linear inequality line, okay, solid circle means that it is inclusive of the equal sign. Hollow circle means there is no inclusive of the sign. Okay, and the last type at the bottom here is where they split it out into 3. Okay, so the rectangle less than the circle less than the triangle. So you split it up into 2. Rectangle less than circle will be 1. Circle less than triangle will be 1. Okay, and remember that in the middle is the word and. Okay, this revision notes has already been sent out. So yeah, you can just take a look at it. Okay. Why do you hate EMF? EMF is a easy subject. So yeah, this is for linear inequalities. Now, for graphical questions, right? Please take note that I think someone asked whether is there a curve. No. There are no curves for inequality questions. That is for AMF. The only ones that we're talking about is the straight lines. Okay, so it's those kind that looks like this. Okay, so just take note of that. Wait, so no shape. Wait, what? Okay, you guys answer lah. Okay, so if you see any questions that you guys can answer, then you guys answer from. Okay, unless I see wrong answers, then I will comment lah. Okay, but so far everything is fine. Okay, so yeah. Look at this. Check out. Solid circle is with the equal sign. Hollow circle is no equal sign. Okay, so just remember this concept. Okay, problems in real world context. Okay, I'm reaching the halfway mark. Okay, so we first talk about exchange rate, compound interest, hire purchase, and taxation. Okay, so currency exchange rate always comes out. Okay, so it's the one where they tell you like $1 is equals to something euros. Okay, so those kind of questions, always remember to always keep whatever the question wants as 1. The rest you can just manipulate normally. Okay, compound interest, this is provided to you. So for compound interest, formula is P, 1 plus R over 100 to the power of N. Okay, this is the compound interest formula. Now remember, compound interest gives you total. If you want to find the interest alone, then it will be P, 1 plus R over 100 to the power of N minus P. Okay, there is a difference. Okay. Next, we go into hire purchase. Okay, so for hire purchase, remember the hire purchase formula, okay, is deposit plus installment. Okay, usually hire purchase is always the easiest answer or easiest kind of questions. Okay, it rarely appears in paper 2. Okay, so yeah, for deposit, right, the question will usually tell you what the deposits will be. Okay, and then for installments, okay, they will tell you like, oh, I'm going to pay for a 24-month installment of a certain price. Okay, so just take note of that. For taxation, okay, taxation rarely comes out for O's, but I'll just go through. Now, whenever you're dealing with a tax, you're talking about GST and you're talking about service charge. Okay, so the GST and service charge percentages usually will be given in the question. So just remember this example. If you're paying for a $100 meal, okay, let's say for example, if I go out with my girlfriend and I spend $100 for my meal, okay, I need to pay for GST, I need to pay for service charge. If let's say the GST is 7%, okay, so if let's say the GST is 7%, then how much I will pay will be 1.07 of the amount, okay, which is $107. Okay, then for the service charge, if let's say it is 1.12%, it's just based on the taxation here. Okay, so just remember this example. Next, we'll go into graphical analysis. Okay, we're talking about the rate using gradients. Okay, and the graphs of increasing and decreasing gradients. So first thing, let's talk about the rate. Okay, so just remember whenever you're dealing with questions that give you like a flat graph or give you a graph, let's say for example, look something like this. Okay, and the question asks you for what is the rate of something increasing or something decreasing. Okay, we are always looking for the gradient. Okay, usually these kind of questions will trick people, so be careful. Okay, this is your gradient. Okay, this is for the rate questions, and for the last one, graphs of increasing, excuse me, increasing and decreasing gradient. Okay, just take note what other graphs look like. This is increasing gradient. Okay, and this is decreasing gradient. Okay, so just take note that these are the few. Okay, if let's say you cannot understand why these are decreasing or increasing, okay, so increasing gradients, right? If you look at my video, okay, increasing gradients always starts from 0, which is like a horizontal line like this, and then you're going up. Okay, so going up like this. Okay, then for decreasing gradient, it's going to be straight down like this, going down. Okay, so this will be your decreasing gradient. Last one will be applications into real world context. So this one I cannot say much. Okay, this one will come out for the last question of the paper. Okay, where this one will be like those kind of 7-mark, 8-mark questions at the very back. Okay, so just take note. For this kind of questions, usually the last part is the most difficult. Okay, most difficult question so far was 2020 last question. That question was quite difficult, but the rest are pretty easy. Okay, so just remember that whenever you're doing application questions, always plot out whatever you need, whatever like, right now, everything lah, basically in the question. Okay, so just write out as much as possible and of course answer the question whenever needed. Okay. Okay, a lot of problems here. What is going on? Wow. Okay, you guys can answer for me. Okay, so yeah. Okay, so yeah, this is problems in real world context. Okay, let's move on. I have a few more chapters. So 1, 2, 3, 4, 5, 6. Oh, sorry, not this. 7 and 8. Okay, 8 more chapters. Should be pretty fast, and I'll be done for today. Okay. Yeah, I'll be sending this document, so don't worry. Okay, so we go on into geometry and measurements. Okay, so for geometry and measurement questions, right? There are two types that haven't come out yet. Number one will be angle properties, but this kind will pair up with properties in circles. Okay, so we know that this chapter hasn't come out yet, so the the angles will appear there. So all your straight line angles, your corresponding vertically opposite, must remember to do. Okay, then must remember to write out every single reason that is important. Okay, every equal sign must contain a reason. Okay, so just take note of that. And the last one is construction. So this one is quite controversial because construction always appears in paper 1. You do not need to write in full sentences. You just need to be logical. Okay, so for example, if the angle property is like angles on a straight line, then write angles on a straight line. Okay, you don't need to say, oh, the reason is angles on a straight line. Don't need. Okay, as long as it answers the reason, that's good enough. Okay, please do not use short form, do not draw symbols, write out the full word. Okay. Now for constructions, right, I know this is controversial because it didn't appear in paper 1, so a lot of people will think to not bring in construction materials, but you never know. My suggestion to everyone is to go and bring, okay, because the chances of it coming out is there, and I know one of the chapters that this can link on to will be coordinate geometry. Okay, these kind of questions can always tap into construction. Okay, so just remember that this is what we need. Okay, and you need to remember the properties of an angle bisector and a perpendicular bisector. When you're talking about an angle bisector, it cuts an angle in half. And for a perpendicular bisector, it will cut a line. Okay, so whenever you are drawing, okay, your construction, you're doing your perpendicular lines, remember a few things that you need to remember to plot. Okay, your arcs must always be drawn. This is for perpendicular bisector. Okay, and for angle bisector, okay, now the jaws of your jaw of your compass, right? Whenever you open it up, okay, must always stay the same. So if you're using 4 cm here, you must use 4 cm here lah. Okay, if you are using 5 cm here, must use 5 cm. Must follow all the way. And then how big you open your jaw, it really depends on the question. We always open to the half of the shortest possible length. Okay, so half of the shortest possible length. Okay. Next one will be properties of circle. So this is my favorite chapter, but everyone hates this chapter for some strange reason. Okay, for properties of circle, right? What do we need to take note of? Okay, so for properties of circle, there is a total of 5 to 6 kind of properties. Okay, so just remember the shapes. Remember what kind of shapes always comes out. So we start first with tangent. Okay, so we go with tangent laws first. Okay, so if you have a tangent, okay, imagine I have a circle here. Now if I have a line cutting, okay, something like this will be tangential to the circle. Okay, this is perpendicular to the radius. Okay, so this is tangent, perpendicular. Okay, this is the first property. Second one. Okay, if let's say I have two tangent lines, they are going out like this. Okay, two tangent lines that are going out like this. So, okay, take note that these two lines are equal. Okay, and the reason here is because tangents extending. Okay, so yeah, this is another property that we need to take note of. Okay, so these are the two most important ones. Okay, so just take note of this. Next one, there are 4 more that we need to take note of. Okay, first one, let's talk about the arrow. Okay, so I'll call it the arrow. Okay, which is this property here. Okay, this property here for these two, angle at center equals to 2 times angle at circumference. So angle at center equals to 2 times angle at circumference. Okay, now just take note that for this arrow shape, there are many different versions of it. It is not just this arrow shape, there are a few more other types. Okay, so just take note, this is for the arrow. For the next one will be angles in a semicircle. Okay, so this one here will be a circle. Okay, this angle here will be 90 degrees. Okay, and this is angles. Okay, this is the next property. Okay, so yep, this is for semicircle. For alternate segment theorem, I will answer it in a while. So hang on, please. Next one will be the butterfly. Okay, so for the butterfly here, please remember to not write butterfly in your exam. It is called angles in the same segment. Okay, do not write butterfly. You get it wrong. Angles in. Sorry, I apologize. My hand is atrocious now. But yeah, angles in the same segment. Okay, so these angles are equal. And the last one here would be the one that I saw someone just now say that it is in AMF. No, it is not. We're talking about cyclic chords. Okay, so for cyclic chords, we have a circle, and we have a four-sided figure in the circle. Okay, remember that the opposite angles are. So this is angles in opposite segment. Okay, so these are the 6 in total. Now, a few things that I want to talk about that I see people spamming in the chat. Number one, alternate segment theorem is only taught in AMF. Okay, so that one, if you want to use, you cannot because it's AMF. Okay, midpoint theorem also not tested in AMF. Okay, so just take note of that. Two more. There was someone that's saying it was a CLT topic. No, that's not true. That's for N level EMAth. Yes, there was a CLT topic there, but this is O levels. Okay, this is confirmed tested. Okay, and yeah, that's about it. Okay, so for all of this now, okay, cyclic chord, if you have never seen it before, it's just angles in opposite segment. Okay, so yep, just take note of that. Now, for formulas, right? Let's say for example, if you want to use something that you have learned in AMAth, please avoid. Okay, so try not to. Okay, and last thing I want to just point out, for butterfly and for the cyclic chord or for angles in opposite segment, okay, the four corners must touch the circumference of the circle. So four corners must touch. Okay, so yeah, the four corners must touch the circumference of the circle. Okay, so yeah, this is a easy chapter, so all the rest later. Okay, next trigo. Okay, so for trigo, right? For trigonometry, right? So the only concept that came out so far was sine rule. Okay, everything else didn't come out, so that's why I believe that this will be another big question. Okay, so for Tokaso, remember that this is a standard triangle. Okay, so Tokaso always works for right angle triangles. Okay, so Tokaso only works for this. Next, for cosine rule, okay, cosine rule is provided during the exams. So it's c squared equals to a squared plus b squared minus 2ab cosine of c. Okay, remember that for cosine rule, there are two types that will always come out. Okay, cosine rule is always, they will give you a triangle missing one angle, or they will give you a triangle with two sides and one included angle, find the last side. Okay, so these are the two for cosine rules. Fun fact, cosine rules are always 3 marks. Okay, so if you see a 3-mark triple question, most of the time will be cosine rule. Not all the time, most of the time. Okay. Hey, stop spamming in the chat, thank you. Bearings, okay. Okay, so for bearings, right? Please remember that for bearings, remember that questions are always phrased in this way of something from something. Okay, it's the same for angles of elevation and angles of depression. They are always phrased in the exact same way. Okay, so where do we draw my north line? Okay, we talk about bearings first. We draw the north line from here. Okay, so let's say, for example, if this is an A and this is a B. Okay, if the B is here. Okay, and let's say, for example, the A is here. Okay, the north line must be drawn at B, and this will be the angle. Okay, now bearings, please remember, if it's less than 100, must put the 0, must be 060. Okay, and always live in 1 dB. Okay, everything I'm saying here important. Okay, so please remember, bearings is always in 1 dB, not 3SF. 1 dB. Okay, 1 dB, not 3SF. I warn you first, it's 1 dB. Okay, angle of elevation and angle of depression. Okay, so we talk about elevation. Okay, so for angles of elevation and depression, they are always phrased in the same way as well. So of something from something. Sorry, my handwriting is atrocious, but yeah. Elevation is of something from something. Okay, remember that we are always interested in where we are starting from. Okay, so let's say if this is A and this is B. Okay, so let's say for example, if I have a B here, B is me. Okay, I see a bird in the sky and I see money on the floor. Okay, depression is looking down. This is the theta. Okay, this is the depression. And this is the elevation. Okay, so one of the ways to memorize this is a very crude way to memorize, but just remember that if you're depressed, means you're sad, you're looking down. Okay, stupid way to memorize, but it's true. Okay, so yeah. Another thing is also, if you look at my screen, okay, you see my video, right? I don't know whether you can see now, okay. But another way I remember is that if you're from somewhere, we always look at the eye line. So I'll imagine a dotted line from my eye. If you're looking at somewhere on the floor, this is your depression angle. okay, and if you are looking up, okay, then you'll be going up. Okay, so this will be the angle that you'll be looking at. Okay, now I understand that the theta is out here in the triangle, but remember when you draw your right angle triangle, by alternate angle properties, this will be theta as well. Okay, so just take note of this. Okay, last one is shortest distance. So write it up there. So for shortest distance, we are talking about the perpendicular distance. Okay, so for the perpendicular distance, remember that perpendicular distance, there are a few ways to get it up. You use either trigo or you use the area method. So area equals to area. Okay, I know it looks stupid, but it's true. Okay, area method means that you take the area using like half AB sine C equals to half times length times the perpendicular height. Okay, shortest distance always appears with questions that like from a point to a line. So that will be the perpendicular line. Yep. Let's see. Bearings, yes, always live in 1 dp, not 3SF. So if your answer is 234.4657891, you write it as 234.5. Okay, so that is for that. The rest I'm gonna ignore. Okay, so this is triple. We go into mensuration. So for mensuration, right? This one is all about the different geometrical shapes. Okay, this chapter will split into two. Okay, we talk about the easier one first, but arguably a lot of people hate this portion also. Arc sector and area, arc length and area of sector. Yeah, I love this portion of the chapter as well. So easy, but no one can do it. So remember the formulas. Okay, r theta and what's the other one? R theta and half r square theta. Yes, thank you. Okay, so these are the two topics here. So r theta and half r square theta. Please read in degrees. Is in radians, my friend. So for r theta, we are talking about the length, and for this one is the area. Okay, so now in the N level paper, there was one question that came out which talked about the arc sector, arc length and area of sector. Okay, but that question they gave the angle in degrees. Okay, so must be careful, because when you calculate out your angles will be in radians, but the answer wants it in degrees. So you must change radians to degrees. Okay, so you must know the difference or the conversions between radians to degrees and from degrees to radians. Okay, so let me just show you the question. Okay, so it was here, this one. Okay, so this question here, the x was in degrees. So when you calculate out your angles in radians, you must be able to convert from radians into degrees. So this is the first time it's done quite a lot of people. Okay, so you must know how to do. Okay, how to convert from radians to degrees and how to convert from degrees to radians. Okay. Okay, now we go back into the main chapter, okay, which is for mensuration. Now, when we're talking about plane figures, okay, plane figures, I think everyone already knows area of a triangle, area of a circle, area of a rectangle, square, trapezium, rhombus, all those kind of shapes. Everyone already knows what they are. Okay, so let me just show you what they are. Because I don't have the time to write everything. So, so sorry about that. Where are you? Here. Okay, so with triangle is half AB sine C, half base times height. Parallelogram rhombus, okay, is just base times height. Must be very careful. There was this year that one question came out, they asked you to find the area of a trapezium. Yeah, and a lot of funky things came out for that question. So be very careful. Make sure that when you're calculating the area of a trapezium, make sure that the line is indeed straight. Okay, not any other thing lah. Don't get tricked by questions like this. I'm talking about 2019 question 21 or 22. I cannot remember which question, but let me find it. If I remember correctly, it is not in this paper. I am so sorry. It's in 2018. It's this question. Okay. This one careful. Okay, so question 22, 2018, this particular trapezium question was not the most easy thing. Okay, so yeah, just be careful. Okay, so next one. This one not important, not important, not important, not important, not important, not important. Okay, we go into solids. Okay, so for those that cannot understand the question later during the consultation, they ask me. Okay, for solids, okay, so remember that there are a few that you need to memorize. Okay, for a prism, remember that it's just base area times height. Okay, that's for prism. For a cylinder, it's pi r square h. Okay, for a pyramid, it's 1/3 base area times height. Okay, for cone, 1/3 pi r squared h. For sphere, 4/3 pi r cube. And then for hemisphere, is 2/3 pi r cube. Okay, all these are formulas that you just need to memorize. Those with the stars are provided to you during the exams. The one for cone, they only give you the curve part. So please be careful. Okay, now this chapter on mensuration, they always tie together with the V1 over V2 formula. So V1 over V2 equals to L1 over L2 cube. And A1 over A2 equals to L1 over L2 squared. Okay, they always link with these two. Okay, the pyramid right angle triangle as base, how to count formula. Your wait okay, sorry. Yeah, for pyramid right angle base, how to count formula. It's just like a standard like one surface. Oh, you just count your base area. Your base area is a right angle triangle. So half base times height multiplied by 1/3 times the height. You get the answer. Standard deviation I answer later. Okay. Okay. So yeah, yeah, just find the um, area of the right angle triangle. Yeah. Okay. So yep, this is for panel figures, and I think that's about it for this chapter. Yeah. Okay. So that's about it for this chapter. So it's nothing much, but just take note that there are a few common shapes that always comes out for O's. One of them is this. If you come for my crash course, you will know what I'm talking about. This shape and this shape. Okay. These two always comes out. Okay. So whenever you want to find what is the height of these kind of figures, remember that we are looking for a triangle in the center, then find the height. Okay, then this is the radius, and this is the radius. Okay, this is one of them. Come out a lot of times really hot. And then this one, they ask you to find the radius. This came out for the N-level paper, and it's done quite a lot of people. How to find the radius? Sometimes they will give you the full height here. Remember that this is also the radius, so you can find this using h minus r. Okay, and then you can find what is this yourself using Pythagoras theorem. Okay, so yep, this is it. If the solid is like a hemisphere on top of a cylinder, do I count the bases twice? No, because the hemisphere is glued to the cylinder. So a very simple way to answer the question is, a very simple way to talk about surface area is how much of the figure do you see? Do you see the portion that is glued? The answer is no. Okay, so the curved part of the hemisphere is glued on top of the cylinder. So that little piece there is not included. Okay. Yeah, for the H, yeah, Ken, give me a sec. Okay, so yeah, let's look at these two. Okay, these are the two most highly tested figures. Okay, so number one, okay, just remember that sometimes questions will give you this full height here. Okay, and you will be asked or tasked to find this. Okay, so just remember that this is R. You can find this. This is H minus R. Okay, and the last line there will be using Pythagoras theorem to solve. Okay, so this is the first most common one. The second one is this. Okay, so just read through this. Now, for the vertical height of a circle that looks like this, a lot of people think that it's just adding up the two circles together, but that is rubbish. Please remember that there is an overlap here. Okay, so this is the misconception. So what we need to do is to do this. From the centers of the circle, okay, we can draw a triangle. Okay, and this piece is a radius, this is a radius, this is a radius. So we can find what is this. Okay, so we can actually find what is the green length using Pythagoras theorem as well. And then this is the radius, this is the radius. Okay, so this is actually how you find the height of a figure that looks like this. Okay, so just be very careful. It is not just a pure stacking of circles on top of each other. You will get it wrong. Okay, it is actually a triangle in the center. Find the height using Pythagoras theorem. Then you add in the two radiuses on the top. Okay, so yeah, this is the way to do it. Okay, very good. Okay, yep, this is the two types out here. Okay, last one, three more chapters. Okay, which is coordinate geometry. Later I will answer later, answer questions later. Okay, so for coordinate geometry, there are a few concepts that everyone needs to remember. Number one, your standard form is y equals to mx plus c. Okay, this is your base equation. Okay, so remember coefficient of y must always be 1. Okay, it cannot be, let's say for example, if it's 2y equals to 7x plus 3, and the question asks you to find gradient, the question asks you to find gradient and y-intercept. What you need to do is to divide by 2. So common trick, huh? Okay, where this is your gradient and this is your y-intercept. Okay, so what's that? For the circle questions, will they ask for the shaded region in so how do we find it? If you're talking about this, sure, possible. How will you find? You find the area of this sector, area of this sector, area of this sector. Take the triangle minus the 3 sectors. You get the shaded region in the sector. Okay, so that is one question, possible question type. Very hard to spot lah. Okay, so just need to know. Okay, yeah, go back into coordinate geometry. Okay, a few more concepts that we need to remember. Let me use my notes to explain this chapter. So, okay. So first one up here. Now, common mistakes. Okay, remember that the coefficient of y must always be 1. Okay, so just take note of that. Now, whenever we are talking about gradients, okay, there are 4 types: the positive gradient, negative gradient, undefined, and 0. Okay, so for undefined, it is a vertical line going straight down, and for the horizontal line, gradients will be 0. Okay, the standard form is m equals to y2 minus y1 over x2 minus x1. Okay, so just take note of that. Just remember also that for vertical lines, okay, the equation is x equals to something. You must remember to put the x. Okay, and then for horizontal line is y equals to beta. Okay, so that will be it. Next one, distances between 2 points. This is Pythagoras theorem. Okay, so it's x2 minus x1 squared plus y2 minus y1 squared. Okay, that is Pythagoras theorem. For parallel lines, okay, the gradients are equal. Okay, so remember that gradients are equal. That's the definition for it. Okay, for vertical and for horizontal lines, please remember if you are lying on a vertical line, all the x coordinates are exactly the same. For a horizontal line, all the y coordinates are the same. Okay. Plus 2 things. Whenever you have a point on a solution, there is a solution or a point lies on a curve, you just substitute the point onto the line and then you solve the point using simultaneous. Okay. Then for the questions where they state like, oh, something's on the x-axis, something's on the y-axis, remember the x-axis means y equals to 0, y-axis means that x equals to 0. Okay, for Edward, you are asking for a different math. That is A math for both of your questions. For shoelace and for area under curve, it's all in A math. So yeah, okay, just be careful. Okay, yeah, this is for coordinate job. Okay. Yes, there's someone that asked that question about y minus y1 equals to mx minus x1. No, that one cannot. That one must use, that one is in AMF, so please do not use that formula unless you derive it from the gradient formula. Okay, so just take note of that. Okay. Yeah. Teach one. Equidistance from x and y axis. You're lying along the line of y equals to x. Ask me later. Oh, okay. How do you find equation of a line using the EMF way? Y equals to mx plus c. Let's say, for example, I have a point 2, 1. So you sub 2, 1. Let's say gradient is 2. And then you just do 1 equals to 2 times 2 plus c, c equals to -3, therefore y equals to 2x minus 3. This is how you do. Okay. So you cannot use shoelace, you cannot use midpoint, you cannot use 1 minus y1 equals to mx minus x1 unless you derive it from the gradient formula. Or else cannot. Okay, so please refrain from using AMAth methods unless super necessary. Okay, 2 more chapters. This one just ignore. I put for fun only. So the reason I put this here, the reason is because vectors will confirm come out as a question. Okay, so this is a question that you do not need to do. So if let's say it's a 10-question paper, you only need to do 9. Okay, so just take note of that. Okay, so this chapter is not in your syllabus, but for those that are moving on to A levels, please remember that this is a monster chapter, and do not throw away the knowledge from vectors. Okay, last 2 topics, and then we're done for today. You guys can start heading to school. Okay, data analysis and handling. Okay, let's talk about the concepts out here. For misinterpretation of data, there are 3 types of answers that we can give. First one is it doesn't start from 0. Start from cosine. Number 2, the pictograms not proportional. Okay. Next one, dot diagram and stem and leaf. Okay, I'll just talk about stem and leaf only. Now for stem and leaf, there are stem and leaf concepts. Okay, just take note that for stem and leaf, there are a few things that you need to remember. The legend, you must remember to draw. Okay, and the second one will be that you need to list all in numerical order. Okay. Next one, cumulative frequency curve and box and whisker. Okay. This one pretty easy, so nothing too much to talk about. Maybe for box and whisker, remember that the concepts are just like this. Okay. So this is your mean. This is your max. This is your 25%. This is your 75%, and this is your median. Okay. So just need to take note of this. Okay, this is for box and whisker. Yes, percentile. Sorry, not percent. Okay, thank you. Mode, mean, median, interquartile range, and standard deviation. Okay, all never come out before. Okay, so just list every single one now. Mode is highest occurrence. I think write it down. This you guys. I did. Okay, yeah. So mode, mean, median. Okay, so for mode, we're going to talk about the highest occurrence. For mean, we're talking about average, and then for median. Okay, now median must be very careful. Okay, so median, right? There is always split between 2. You can have a median of odd numbers or a median of even numbers. Okay, so when you have a median of odd numbers, this means that we're going to split the whole class exactly in half, and you round out the value. So let's say, for example, if my data set is 15 people, to find the middle, it's just 15 over 2, round up to 8. Okay, and that will give you the median of the odd number of people. Now, for the even group of people, okay, you need to find what is the lower bound and the upper bound. Okay, so what we do is to just take the data set, divide it by 2, and this will give you the lower bound. Okay, so the lower bound, let's say, for example, if the set is 16, okay, then 16 divided by 2 is 8. This will give you the bottom bound of the even data. Okay, then for the 9 will be the upper bound, just plus 1, and then you go smack in the middle, that will be the median. So that will be 8.5. Okay, so this is how you calculate odd and even. Okay, for odd numbers, don't need to plus 1, don't need. I have never plus 1 before. I just round up. I mean, it's up to you how you learn it. For me, I round up, but it's the same thing. Okay. Box and whisker I already went through. Yep. Next, the differences between range and interquartile range. Okay, range is 100th percentile minus 0%, so it's max minus mean. Interquartile range is 75 minus 25. Okay, so that is for interquartile range. For median, Okay, the formula is provided for you. Okay, so n plus 1 over 2 is the same thing. You get the same answer. Okay, so for mean, it is provided. Okay, just need to remember that is summation of fx over the summation of f. Okay, so the summation is the sum sign, frequency is f, x is your data set. Okay, x is the middle of your class interval. Okay, so for example, if let's say we are talking about between 0 to 20, middle is 10. Between 0 and 15, middle is 7.5. Okay, standard deviation is this big ass formula here, provided in the formula sheet. So it's a summation of sums fx squared over f, summation f minus the group mean squared. Okay, so remember, this is how you break it down into the two. Okay, it really depends on how many marks your question is. If the question is more than 2, remember that you need to draw working, you need to write the workings down. If let's say it's a 1 mark standard deviation question, you can use calculator. Okay. Last thing here is talking about the comments. Okay, so this one is when they ask you to make a comment about the data. There's 2 that you can talk about, or actually 3: median, standard deviation, and range. Okay, for median, remember that the bigger your median, the bigger your data. Okay, so let's say for example, if I have 2 batches of chickens, okay, group A's mean is 20 kg chicken, group B's median is 25 kg chicken. So you can just say group B's chicken weighs heavier because of the higher mean. This is what I mean by that. Okay, so group B's chickens are heavier because of the higher median. Or group B's students are taller because of the higher median. Okay, so it really depends on the question. For standard deviation, remember that it is a complete flip between the two. So the bigger your standard deviation, the smaller the consistency. So standard deviation is talking about how far your points are from your best fit line. Okay, so for standard deviation, okay, remember that the bigger your standard deviation, the smaller the consistency, the smaller the standard deviation, the more consistent the data is going to be. Okay. Yeah, I'll answer questions in a while. Okay, so let me just finish talking first. Okay, and the very last thing here will be, yeah, probability. Okay, so probability, nothing too much here. Okay, because there was already one question, and the question was chicken fillet. Okay, so probability of 2 data or more never come out. Okay, so for example, it's like 1 black, 1 white. That one never come out. Okay, they only test you so far for single probability. So for this kind, remember that you must draw your possibility diagram or your tree diagrams. Okay, and just some notes for everyone. Okay, possibility diagram is the one on top. Make sure that you solve it out properly. Now for tree diagrams, remember that if you're going with replacement, remember that your denominators do not change because you're replacing. But if you're going for without replacement, then the denominators will change. If the first row is n, then the left will be n minus 1. Okay, so the first row is n, next row is n minus 1, next row will be n minus 2. Okay, and yeah, the last thing is that whenever you are going down the different branches, let's say for example, if you're calculating the probability of red is a multiply. Okay, so down the branch will multiply, but if you're jumping from branch to branch, so jumping down, then you'll be multiply and plus. Okay, so these are the 3 things to take note of. Okay, and I'm done with the predictions. Okay, so yep. The only thing left to talk about, okay, is what kind of questions will appear. So this is something that I already went through with my students yesterday. So number 1 will be all the algebra questions will be classed in 1, I think. Okay, then the other ones will be the monetary questions. There will be maybe question 2. Okay. Question 1 for the question 1, let's say for example for the algebra questions, they will test like simultaneous graph sketching, indices, solving quadratic equations, all in the exact same question. Okay, so just be prepared for that. Okay, second one, they will test the monetary type of questions. Okay, so that one will go for exchange rate, compound interest, hire purchase, taxation, yeah, all those kind of questions lumped together. Okay, and then just take note of the 4 chapters that I've mentioned, 3 chapters that I mentioned here. Properties of circle, mensuration, coordinate job, because these are very fresh chapters. They never come out before. Okay, so These will most likely be your big questions as well. Number patterns will also be your big questions as well. Okay, and trigo. Okay, anything can come out, you really don't know. Okay, so I think I need to end off soon. Okay, so I just want to say, okay, I know of the technical difficulties and everything. Okay, I do apologize. Okay, for all the technical difficulties in the morning. Okay, didn't predict that there will be more than 300 over people. Okay, so for the AMAth session next week, I will be hosting one as well. Okay, that one I'll preempt for more people. Okay, so yeah, thank you very much for the support. Didn't expect there to be so much of a turnout. Okay, I hope everyone learned something today. All the best for your paper later. Okay, yeah. Right now we will kickstart the consultation portion. So if anyone has any questions, you can just start spamming into the chat. I will start reading your questions. Okay. And yeah, that's about it. For those that wants like a little review of the paper one, you can stay back. Okay, I'll not be recording this portion. For those that want to see like my solutions for the paper one, you can stay back. I can give you my opinions on it, and I can tell you like how I would think the paper two will be about later. Okay, so I'm going to stop the recording. Thank you very much for coming today. And for those that are staying for the remaining portion, I see you in a while. Okay, thank you so much. Bye-bye.
Oh, thank you.